These tomatoes require 90% less irrigation than normal, and they're extremely resistant to drought. If they could also taste good, have a nice texture and provide a steady yield, they'd be the dream of every tomato grower. We meet the scientists who say they're trying to turn this dream into reality in the north of Israel.
Some 40,000 tomato plants from 200 different varieties are being grown on this experimental field. For some of them, life is hard. They only received irrigation for 3 weeks at the start of the season and didn't get any more water over the long, hot summer.
Behind me, the big plants got water, so it's very basic fact that a tomato that got good nutrition and water will grow bigger. But we want to see without the water, without irrigation, who can still give us a good yield and good bricks, and maybe we can move on with it to a bigger experiment.
Finding out how to develop drought-tolerant tomatoes is one of the goals of a European research project aimed at identifying new ways of increasing tomato yields. Researchers here think the answer doesn't lie in genetically modified organisms, but in nature itself.
Our approach is to use natural biodiversity in order to identify traits that come from wild species that are related to core plants, and transferring these traits through conventional crosses into modern tomatoes and achieving a tomato that has the old traits plus an additional bonus trait that comes from the wild species.
To become a market reality, drought-tolerant tomatoes must first meet certain criteria. Every season, some 700 varieties are assessed in this lab. Over time, the centre has built up a collection of seeds from 12,000 different varieties of tomatoes.
We make a great deal of the taste. So we try to get a high sugar content and as well different tastes and aromas of the fruit. Also, we try to focus on the color.
Once promising candidates are identified, their DNA is carefully studied. Plants with specific genetic traits will be interbred with wild species to come up with new, improved versions.
We're screening hundreds of DNA samples, and from those hundreds of DNA samples, we can see which ones are the ones that have resistances. They're going to be strong. They're going to be the good tomatoes in the end. And we can continue with those specific lines and breed those.
Similar research is being applied to develop species not only resistant to drought, but also to pests and disease that also adversely affect tomato yields.